Hi students, problem number 9. A wire of length L is bent in the form of a circular coil of some turns. A current I flows through the coil. The coil is then placed in a uniform magnetic field B. The maximum torque on the coil can be. So very interesting problem and also very simple. So you can look at the diagram. So in the first diagram, a long straight wire is having a length L. Next, it is bent in the form of a circular loop of radius R, and then a current of I ampere is passed through it. So the circumference of the circular coil must be equal to L. Is it not? L is the length of the wire initially before bending. After bending this into a circular loop, I can write L is equal to 2 pi r, that is the circumference. Therefore, what is r equal to L divided by 2 pi. So this is the first information we must get. The radius of the circle is expressed in terms of the length L. Okay. Now the magnetic moment of this circular loop, okay, carrying a current I is equal to current into loop area. So it is a current into loop area. Therefore, what is M equal to? Therefore, M is now equal to the current I into loop area is pi r square. So this is pi into r square. Or M is now equal to current into pi into radius R is equal to L by 2 pi. So R square is, this is L by 2 pi the whole square. Therefore, what is M is now equal to I into pi into L square divided by 4 pi square. So this square and pi term get cancelled. Therefore, the final expression for the magnetic moment is equal to IL square divided by 4 pi. So this is the second information we must gather. Have you all understood up to this step? So magnetic moment of the circulating current in the loop is equal to the current multiplied by the loop area. From that I have got M is equal to IL square by 4 pi. Now, when it is placed inside a magnetic field B, it will try to rotate with a torque. When is the torque maximum? What is the expression for the magnitude of the torque? Torque tau is equal to what? M into B into sine theta. For maximum torque, torque maximum is equal to M into B into sine 90. Sine 90 is equal to 1. Is it not? So, this is now equal to M into B. Therefore, tau maximum is equal to this I L square by 4 pi is multiplied with the B. So, this is I L square by 4 pi is multiplied with the B. That is the final answer. So, the maximum torque acting on the coil is given by tau maximum is equal to IL square B by 4 pi. Okay. So which option is correct? You see here, this is 2 pi. So this is IBL square by 4 pi. So IBL square by 4 pi. That is the correct answer. Okay. Now we find that option B is the correct answer. So what is the option B? Tau maximum is equal to IL square B divided by 4 pi. That is the right answer. Very simple idea only. So what is the base formula you have to remember is when a straight wire is bent in the form of a circle, the initial length of the wire is equal to the circumference 2 pi r. And then you have to remember the formula for the magnetic moment in a current loop, that is equal to the current into the loop area. Then by substituting, the third expression you have to remember is the magnitude of the torque is equal to what? MB sine theta, and for maximum torque sine theta is equal to 1. From that we have to derive the answer. I hope you must have understood well. Fine.